Good morning, this is your stats sensei, Mr. Spensey, and it's still a fluid situation, and we're going to be doing our exit ticket. And this is going to use the problem from our warm-up. It says use a 95% confidence interval to estimate the difference in proportions of people getting sick with the flu. So first off, I'm going to go ahead and fill in my sea level because I already know it's 95%. All right, so 0.95 is my sea level, or 95%. The scenario is this. A study was conducted to determine if taking vitamin C reduces the occurrence of the flu. The study was conducted using 808 student volunteers who did not take a flu shot. The subjects were randomly assigned to one of two groups. Hey, this is going to be really important, that random assignment. If it's random assignment, we get rid of one of our conditions. The treatment group who received 1,000 milligrams of vitamin C daily, and a control group who received a placebo flavored to taste like vitamin C. All participants were monitored to ensure that they adhered to their assigned treatment record on a daily basis throughout the period of the study. At the end of the flu season, each subject's medical record was reviewed by a physician to determine whether he or she had contracted the flu during the period of study. The physician did not know which treatment each subject received. The results of the study are shown in the table below. Awesome. So the placebo group, there was 405 people in the placebo group, and 331 of them got the flu. Well, we probably need to fill that out. So I'm going to call this the placebo, and this is the vitamin C, VC group. And it apparently 405 got the placebo. So that's my sample size is 405. And of that, 331, when we look at the table, 331 of that placebo group got the flu. So 331 out of 405. On the vitamin C group, we had 403 people, and 302 still got the flu. So 302 out of the 403. So from this, I can get p hat 1 and p hat 2. So this is going to be 331 divided by 405. 331 divided by 405. And that's 0.8172. And then we have 302 divided by 403. And that's 0.7493. Awesome. So now that we have that, let's go ahead and get to our conditions. So first off, it's not a random sample. They said it was random assignment. Oh, and this is the placebo side. And this is the vitamin C, the VC side, vitamin C. And hopefully that will clear up in just a second because we just got real blurry. There we go. All right, a little better. So random assignment, not random sample. So random assignment, and that was given. And that's also true here, of course. They didn't tell me how they were random assigned, but maybe they flipped a coin. I don't know. Maybe they put the names in a hat and drew. Two independent groups. And that was given. Three, that's the n is less than 10% condition. Well, guess what? With random assignment, we don't do that one. So we need to drop down to our normality. Now, this is different than for the hypothesis test. With the hypothesis test, we have to do p hat c, but here we're going to use p hat 1, so n times 1 minus p hat 1. So we'll use p hat 1, and over here we'll use p hat 2. Well, my sample size for 405 times 0.8172. And I know that value equals 331, and that's greater than or equal to 10. And then 405 times 1 minus 0.8172. And I don't know exactly what that's going to be. So 405 parenthesis 1 minus 0.8172, close those parentheses, and I get 74. And that's greater than or equal to 10. So both of those are taken care of. Then over here, it's n times p hat 2, and then n times 1 minus p hat 2. So this is going to be 403 times p hat 2 is 0.7493. This value I know. That happens to be the number who got sick, which is 302. And that's greater than or equal to 10, so we're good. And this is 403 times 1 minus 0.7493. So 403 parenthesis 1 minus 0.7493. And we get 101. And that makes sense because those add up to 403. And that's greater than 10. All right, so both samples are large enough. This one is large enough. This one's large enough. We're good to go. All the conditions have met. All right, so our formula for a confidence interval is p hat 1 minus p hat 2 plus or minus z star p hat 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 over n2. So in this case, we're going to go inverse norm. And our area is 1 minus 0.95. As I said, run a 95% confidence interval divided by 2. And if your calculator does left, right, or center, it's just easier to go left. So second vars inverse norm, second vars inverse norm. 1 minus 0.95, close the parenthesis, divide by 2, mean is 0, standard deviation 1. We have left. And we're going to get a negative number, but we're positive people, so we're going to make it positive. So 1.9599. And then I need to plug in. So I'm going to be short on space. I'm going to do the best I can to fit as much as I can. I'm going to shorten these down and I'm going to round them. So this is going to be 0.82 and this is going to be 0.75. So this is my p hat 1, 0.82 because I rounded, minus 0.75 plus or minus 1.9599 and p hat 1, 0.82. 1 minus 0.82 is 0.18. Here's where that came from. 0.82, oops. 1 minus 0.82. That's where the 18 came from. Put that over my sample size of 405 plus this sample size is 403. We said we're going to round that 0.74 to 0.75 just so I have enough room. And when I do 1 minus, that's going to be 0.25. 1 minus 0.75 is 0.25. And we're going to go ahead and calculate our interval. So, stat, test, drop all the way down to letter B, 2 proportion Z interval. And we have 331 who got the flu out of the 405 on the placebo. 302 got the flu out of the vitamin C group out of 403. And we need a confidence level of 0.95. And there's my interval, 0.01128. 0.01128 or 112 to 0.1245. Now, what's interesting is 0 is not contained. All right? Zero is not contained, and it's positive, and placebo must have been larger. So more people got sick with the placebo, and because 0 is not contained, it is statistically significant. And because this is an assignment, or random assignment, this makes this an experiment. And we can say that people fewer people get sick if they take vitamin C versus a placebo. All right, appreciate you watching, and I hope to see you on the next one. Thank you.